Exercise 6L application problems. Today we are learning about application problems involving circular functions, and what you need to be able to do is break down a worded problem to understand what you need to find and then identify the key values and points provided to help you solve that worded problem. Our first question always is, where could we possibly use circular functions? Well, the answer is anywhere that you see an up and then a down motion. So something that is continuously going up and down, such as the tide, temperature, sun level, and even the height of circular objects such as Ferris wheels. They're also commonly used in things like sound waves, and you'll definitely be using this if you go into a field of engineering. So without further ado, let's start example 16. It is suggested that the height, ht meters above the tide, above mean sea level on the 1st of January is given by that particular rule, where t is the number of hours after midnight. So I'm already going to write this point here, where if t is the number of hours after midnight, that means when t is 0, that represents midnight, which is 12 a.m. Part A, draw the graph of y equals h of t between 0 and 24. Of course, we can do this by hand, but we do want to practice using our CAS calculator skills. So what we're going to do is move over to our CAS calculator, and we're going to type in that function there. So that'll be 4. My CAS calculator looks just a little bit different to yours, but it is still the same thing. So I'm going to go to graph edit function, 4 sine pi. Remember, instead of using t, we're going to need to use x so that the calculator can recognize it. And what we'll also do is put the domain in. So your domain is if you press Control equals, the equals that is underneath it. Mine doesn't quite work that way, so I have to type it in a different way. All right, and I'll press enter, and there's my lovely graph. Now, as you can see, the zoom isn't quite correct, so I'm just going to move my screen over and pinch out a little bit. On your CAS, you can move it over, but the way to change the zoom is by double tapping that particular value and then changing it to anything you might like. So in this case, maybe 25. All right, to find it, we're going to need to put in our x-intercept. Because I know my period is 24, my period is 12, but I've got 2 cycles, which is 24. I can tell that the halfway point will be at 6, but just to check anyway, we'll go to Analyze Graph 0, and then we'll select our lower bound, upper bound, and we can do that for each of our points. Not maximum, that's not what we need. We want the intercept. So that's 0. That's 12. Make sure you're practicing along with me. So those are all of our key points. In a bit, we also will need to find the maximum. You can figure that out also through the amplitude, but we can see that the maximum here will be 4, and the minimum will likewise be -4. All right, so that's our full graph, and now we can go ahead and draw that. Make sure we put t, and we can write h of t since that's the value of this function, the variable. And just put in all of those key points. Oops, that was 12. Okay, so that's your part A completed. Part B, when was the high tide? So when is asking us at what time, and the high tide we can see occurs at this particular point, so the highest point that it's going to be. So we can have a look either by finding the maximum and the, as we just did, of these 2 points, or you can take the average between 0 and 6, which in this case will be 3, and then the average between 12 and 18, which would be 15. Of course, we want to try and represent this with appropriate times, so that would be 3 a.m. and 3 p.m. Part C, what was the height of the high tide? So just where it got the highest, that's 4 meters, that's going to be the highest point. Part D, what was the height of the tide at 8 a.m.? So at 8 a.m. means that t is equal to 8. We can substitute that directly into our equation. Once again, it is solvable by hand, but to practice the CAS calculator, we're going to go ahead and type that in. So what we need to do is add in our calculator page. We have already defined this function as f1 of x, so we can just write f1 of 8, press enter, and it'll give us our value right away. So that's -2 root 3. So when time is equal to 8, the height is -2 root 3. And if you want to represent that appropriately, we will say 2 root 3 meters below sea level. All right, and to our final answer, or question rather, that's part E. A boat can only cross the harbour bar when the tide is at least 1 meters above mean sea level. When can it cross? So if I were just to draw a little sketch of what's happened, basically we've got this particular height, which is 1 meters, and it can only cross if it's between these two values, so above it. So that means I'm looking for these x values over here. Because it's time, we don't need to represent it in exact values. That is probably the only exception where if it doesn't say to what decimal place, you don't need it as exact, because time will never be exact because we have seconds, milliseconds, and so on. So in this case, I can actually just use my graphs page to be able to find all of those intersection points when it's equal to 1. So we can go back to our graph, and what we can do is enter in another line, and that line is going to be 1 meter. So y equals 1 is the line in which we know it has to be above. And then to find all of those points, instead of going one at a time, what you can actually do is go to geometry, points and lines, intersection points, and then select the two graphs that you want to use, and you'll see that it automatically pops up with all of them. So those points there are all of our intersection points. The only thing that is unfortunate with doing it like this, you can see that some of them are to 3 decimal places and some of them are to only 1. So that is something that can be inaccurate, especially with time. We want it to at least 2 decimal places. So in order to ensure that I am more accurate, I am going to go ahead and solve it with my normal calculator page, just to make sure that I've got the right number. So we're going to go to solve f1 of x equals to 1 meter, comma x. And I already put the domain in, so I don't need to do it again. As you can see, I've got quite a crazy answer, so I do need to convert that to decimal. You can easily press Control Enter. Unfortunately, I can't do that on my calculator, so I'm going to quickly just convert that to decimal, and we can see our 4 times now to more decimal places, so it's a lot more accurate. So what are our 4 numbers? Well, I'm going to have 0.48, 5.52, 12.48 and 17.52. So that's each of these values over here. And I can see that the boat can cross between these two and between these two. So we just now want to present our answer in a more reasonable manner. So first thing I'm going to do is convert each of these into an actual time. The whole number represents the hour, so 0 means that it's going to be 12 a.m. and then the 0.48 tells me that it's 0.48 of an hour. So to find out how many minutes that is, I can go 0.48 times 60, which will be 29. So that will be 12:29 a.m. I'm going to be doing the same with the 5, so that's representing 5 a.m. If I do 0.52 times 60, I will get 31. And then the next two are the same as above, but for PM. And finally, I just want to represent my answer in a worded form. So I can say between 12:29 and 5:31 a.m. and between 12:29 and 5:31 p.m. And there's your final answer. Example 17. The depth of water d meters at the end of the pier at time t hours after 10 a.m. is modelled by this particular function. Now again, I'm going to highlight this idea, t hours after 10 a.m. That means when t is equal to 0, the time is going to be 10 a.m. So we need to keep that in mind for the future. Part A, what is the maximum and minimum depths of the water? Again, I can quickly sketch this on my CAS calculator to be able to figure this out, or I can do this by hand, probably faster. Usually my sign maximum minimum is 1, but the amplitude is 2, so it's going to be 2 and negative 2, and then I'm going to add 2.5 to it. So that will be a maximum of 4.5 meters and 0.5 meters. Part B, what is the period of the function? Again, we can sketch it, or we can quickly see what the end value is. 2 pi divided by pi on 6. The pi's cancel, the 6 flips, 6 times 2 is going to be 12. That's my period. Part C, what is the depth at 1 p.m.? So we have to be careful. Remember that t equals 0 is 10 a.m. So t equals 3 would be 1 p.m. because that's 3 hours afterwards. So what I'm doing is I'm going to substitute 3 into the function. It is probably easier to just type this straight onto your CAS calculator. So let's go ahead and do that onto our CAS. Okay, and when I press enter, I get 3.5. So what is the depth at 1 p.m.? It will be 3.5 meters. Part D. You'll notice that this is very similar to the first question, so if you feel like you've got the hang of it, feel free to skip this part. If a particular boat needs a depth of at least 4.2 meters to dock, during what times to the nearest minute can the boat dock? So what we need to do here is similar to before. I will go ahead and sketch it just so I can have an idea of what the graph actually looks like. So if we go through to our graphs page, I might create a new one so that it doesn't overlap. I'll quickly type this graph in, remembering to use X instead of T. In hindsight, it probably would have been easier to just quickly define this earlier on, and then we could have just used the function over and over again. That's why it's really important to read in reading time so that you know exactly what you might need to define and what you don't need to. Actually, in terms of the domain, they haven't actually given us a domain, but because this is time and one cycle goes for 12 hours and then it's repeated, it's very clear that it's a daytime and the day has a period of 24 hours. So that's why I'm going to make it between 0 and 24. Okay, so here is my graph. Again, you can zoom in and out as you require. And what we need is for it to be above 4.2. So again, I can go to graph entry and edit. I can add 4.2, enter. We can do the same thing as before with the points on, but it probably won't be as accurate. So what I'm going to do is I'm going to go ahead and solve it. So I just want to quickly check what did I define it as so that I don't have to rewrite it. It's defined as f of 3. So if I go to my calculator page, I can now go to menu, algebra, solve, and it's f of 3, x equals 4.2, comma x. It's already got a domain, so we don't need to. And there you go, you've got all of the t values that is required. So we're going to go ahead and write all of these to 2 decimal places. I'll just give this a little quick sketch just so that you know what it is that we've done. And we need these 2 parts here because we need it to be above. So we've got x is 3.94, rather it's probably better to write t. T is 6.06, T is 15.94, T is 18.06. Now the key thing to remember here is that once again 3 does not mean 3 a.m. or 3 p.m. In fact, it will mean 1 p.m. because it's 3 hours after 10 a.m. So we just have to remember that. So that's going to be 1 and then 1 p.m. And then to figure out what the minutes are, we're going to do 0.94 times 60. And when you do that on the CAS calculator, you'll get 56. So that's 1:56 p.m. Then we will do that again for this section here, 06. So 0.06 times 60. When we do that on the CAS, that's 04. And that's 6 hours after 10 a.m., which will be 4 p.m. And then what's happening is because this repeats exactly 12 hours later, then these will be the same by AM. And finally, we just need to write when it's between. So we know it's between these 2 values. So it'll be between 1:56 p.m. and 4:04 p.m. and between 1:56 a.m. and 4:56 a.m. Okay, next example, example 18. On the same set of axes, sketch these 2 particular graphs. So I'm just going to put this straight onto my CAS calculator. I'm going to add a new page and let's put these in. I will put in the domain as well just to make things a little bit more clear. So there's my first graph, and then I'll do that again for the second one. Okay, and there's my second graph there. This obviously doesn't give us any particular values, but we know that the endpoints are pi on 2 and negative pi on 2. And we can also assume that because that's the average value, for example, for sine, then the minimum is going to be between that, which would be pi on 4. So let's go ahead and translate this into our question. So we had one graph that looked like this, and then the other graph looked like this. And we know that our domain, that's pi on 2, that's negative pi on 2, and because this is midway, that would be pi on 4, negative pi on 4, that would be positive, and that would be 0. We can also see that their amplitudes are different. In fact, the sine graph should actually have a larger amplitude, which is not necessarily something I have represented, so just go ahead and fix that up a little bit. So the sine graph should have a larger amplitude than the cos graph. So excuse that little bit of a dodgy drawing, but that's what it looks like. So that'll be x and y. All right, part B, calculate the exact coordinates of the point of intersection between the 2 points, 2 graphs. So what I'm going to do at this point is I'm just going to put that straight into the CAS calculator. However, because these are 2 interesting graphs, I just want to show you how you would start off if this were a non-calculator exam. So I won't do the whole thing, but I'll just start you off by hand. So if you have a situation where you have to equate sine and cos, there's only one and one thing only that you would do, and that is divide both sides by cos, because that would cancel out the cos section, and then sine on cos is equal to tan. In addition, I'm just going to divide both sides by root 3, just so that I can get that out of the way. So that becomes negative 1 on root 3 is equal to sine on cos, which is tan 2x. Now, why is that so important? Because here is where we just solve our normal functions, or our normal angles. So if I take the tan inverse to the other side, then this is where I start talking about my base angle is going to be tan of what gives me 1 on root 3, which would be pi on 6. I would talk about the fact that tan is a negative in both quadrants 2 and 4, and that's pi minus theta, that's 2 pi minus theta, that's what 2x equals to, and you would find all your angles and so on, and you can solve for x quite easily. So we aren't going to do all that, so all you need to do is you just need to put that into your CAS calculator, and when you do put solve onto your CAS for these 2, I trust that you know how to do that. You will get your answers being negative pi on 12 and 5 pi on 12. Just wanted to do a quick word of caution for you on the CAS calculator. Even though you've defined both of these with the domain, what you need to do is just make sure that you put the domain again, because it can't read 2 domains together, so it just wants one domain on its own. Okay, so now that I know that, I can go back and input that in. So this point of intersection here is negative pi on 12. And then this one here would be 5 pi on 12. Of course, we also need our y values, so we can input that into either graph that we've solved for. So I'm in f of 6, for example. I'll go to my calculator page, and I'll go f of 6 of my first solution, so that was negative pi on 12, and I can see the corresponding value is negative root 3 on 2. And then for the second one, I can do the exact same thing. Actually, the x is 5 pi on 12, and I get root 3 on 2. Okay, there you go. So those are your 2 intersection points. So then for part C, it says this, hence state when that graph added together is greater than or equal to 0. How does that relate to what we just did? Well, what if I took that cos over to the other side? That's exactly the equation that I just solved. And I know I just wrote an equal instead of the inequality, but I want you to think back to when you did quadratic inequalities in year 11. The way to solve it was to firstly change the sign to an equal sign. Secondly, to be able to solve this particular equation when it's equal to each other or when it's just got an equal sign. And then thirdly, you need to sketch and observe what it's going to look like. So that's our next step now. We've actually already found what the solution of this is. That's negative pi on 12 and 5 pi on 12. Now, how does this apply when we sketch? So I'm going to go ahead and sketch this on the CAS calculator. I'm going to add another graphs page, and we're going to type that in. Probably should have put in a domain. There we go. So that is the graph of those two added together. So we can go ahead and draw that in. So what we know is that when we solve these two equations, so it's the same thing whether it's there and I solve it to 0 or I've taken it over to the other side, these are the points that I've gotten. And how does this help? Well, this is saying it wants to know when it's greater than 0, as in when is the graph positive? And we can see that the graph is positive above the x-axis. So that's in between these two x values. So the answer to this is that that graph will be positive when x is greater than pi on 12, but less than 5 pi on 12. So that's how you would solve inequalities using circular functions. Part D, we've got a new function now. For the function defined by f of x is equal to this, calculate f of 0 and f of pi on 2. So I'm going to just substitute these values in. I might just define the function just in case we need to use it a little bit more in a moment. So I can just define it here. Okay, so that's now going to be defined as f of 8 when I press enter. Calculate f of 0, so I can go to my home page, or my calculator page rather. So I want to know when is f of 8 of 0, that's negative 1. And then how about pi on 2? We'll do the exact same thing. That will be positive 1. Okay, so those are those two values. Part 2 then says sketch the graph between negative pi on 2 and pi on 2, and then hence state when it's greater than 0. So it's exactly the same thing. So luckily we've already kind of sketched it. I just want to go ahead and sketch it within that domain though. So we'll go back to that graph. And now I'm just going to add in a domain. Okay, so that's what this graph looks like. So I can quickly draw that in. So actually, I think I drew that incorrectly. Let me try that again. I continued it. Sorry, there's too many things open. I continued it just a little bit too much, so I should have stopped there. Okay, how do I find these two values? Well, all I need to do, as I did before, is just solve this equation, but instead of having the inequality, I would have an equal sign. So I'm going to go ahead to my calculator page now, and I'm going to put in solve. I don't know how that just happened. And we've already got a domain, so I don't need to write one. So that's negative 5 pi on 12 or pi on 12. So that's negative 5 pi on 12 or pi on 12. My graph probably doesn't represent these values very well. But the point is that it wants to know when is it greater than 0. So it is before that point and after that point. But remembering that the graph ends at pi on 2, negative pi on 2, and at pi on 2. So when is it greater than 0? Well, it's going to be between these two x values. So when x is between negative pi on 2 to 5 pi on 12, and, or rather, between these two values. So that's pi on 12 to pi on 2. And it doesn't matter whether you write it in set or interval. This question I wrote in interval, the previous one I wrote it in set, so it doesn't matter unless they specifically ask. All right, that's it. That's the end of chapter 6. Thank you for tagging along with all these videos. I hope you've enjoyed them. Please let me know if you have any feedback, and otherwise, good luck with your upcoming SAC.